Okay, well, speaking of low lake levels, this is a picture John Neal sent of Kyle out in the Stansbury mudflat area where we typically do our shorebird HRV survey. And as you can see, it's a lot of exposed microbialites, and I think the survey takes quite a bit longer now.
Very slow.
And another sort of new, of course. That seems about right. So now why isn't this moving at all? Okay, now it's working. Another new thing we saw on our last shrimp run, and I think Dave from the marina said he had seen them 3 weeks before that. So about a month ago, newly exposed microbialites just north of the marina. So that cone is on the other side of the dredge channel that we drive through. And that's another view in the left-hand corner, but those went on for like basically the whole channel. And there's seagulls on them and birds using them like nesting islands. Pretty crazy. And Dave said he had never seen it before, so it could be the first time those have ever been exposed. It's kind of weird when you're in a giant boat driving next to exposed land. Yeah. To say. Okay, so we'll get right into lake temperature. It's a pretty typical year. We did get pretty warm this June and July, but we're starting to cool back down. It looks like a little early, but nothing's too crazy here except just warm temperatures as usual, like we've seen the past 5 years. I think we've seen a lot of days above 100. Salinity is really high right now. So we started off high in January at about 15.1%. Remember, we take the surface salinity. So we use a refractometer at the surface, and now it's around 16.3%. So it is one of our saltiest years. And I think that also has to do with the fact that we ended and started the year salty. Chlorophyll looks pretty weird to me. We had some low numbers in January, and as soon as the snow melt happened, and it kind of happened early this year in February, we saw a lot of nutrients like dump into the lake and our chlorophyll levels went up, and then they dramatically dropped, and we were at almost like 0 for June and July and part of August. Cyst density is the highest we've seen it this time of year. We did start off really high too. So in January, we had 105 cysts per liter in the lake, and now we're seeing it at 297 on average. So it's very high, definitely an outlier. I should explain if people aren't familiar with these graphs. I think everyone except maybe a few people. All the different color lines in the background are the past 23 years of data. The dark red line is this year, and then the black is the overall average. For nauplii, we started off pretty typical, and we do believe that there was a really big spike in nauplii probably in March or April, but we weren't able to get out as often this year because we were only going out every other week due to COVID. And then there was also like pretty windy and bad weather in February. So there was a 3.5 week period where we didn't get out between February and March. And I think that the nauplii hatched early because if you look, the chlorophyll drops right then. So something had to be eating that chlorophyll. And I think we just missed the sample run. And then we had another small generation of nauplii in late May and early June. And right now we're seeing about 0.1 nauplii per liter. Juveniles, obviously, if we missed that nauplii first, we missed the juvenile bump too. But we are really low again, so there's not a lot of nauplii or juveniles in the lake right now. Closer to my computer. Females, we do have pretty high amounts of adults right now. Right, we're sitting at about 0.8 females per liter, a little bit above average. It usually drops off around now. Females with cysts has been pretty interesting. We did see it's just like jumpier this year rather than a gradual increase in females with cysts. As soon as they ran out of food, they started making them. A little bit of food came back, they stopped, and now there is no food in the lake and they're making cysts. And we're seeing about 0.1 females with cysts per liter. And then males doesn't look too different from the overall average. We're seeing about 0.9 males per liter. But if you add up females with cysts, females with eggs, and males, and you get total adult density. You will see what you have,
That's names of disturbance.
but we just don't have a lot of nauplii or juveniles. And then the forecast that everyone is waiting for. So our spring cyst counts, the low was 64.73 and the high we had 105. Like I said, we had quite a few cysts this January actually, and that puts the fall prediction between 44 and 24 cysts per liter right here on that density dependent curve with an average fall prediction of 34 cysts per liter. If you remove the outliers or high streaks, which is twice the standard deviation, you get a little bit higher outcome with 56 cysts per liter as the fall prediction, but it's still pretty low. I want to point out that typically this prediction is ran off of 4 sample runs in January, 4 sample runs in February, and maybe 1 or 2 in March. This year we were only able to get 2 sample runs in January and 2 in February. And by the time March rolled around, there are already a bunch of nauplii in the lake, so we didn't include that data. And with that data was also really variable. So we had a lot of sites that had low numbers of cysts and a few with super high numbers of cysts, and it made our standard deviation really high. And so there could be some error as well. So that's it. I'll take any questions if you have any.
So our actuals are 4 to 5 times the prediction.
Yeah. Yep.
And that's the other thing is what are these cysts doing right now? Are they just carryover because of the lack of phytoplankton, lack of nutrients coming into the lake, phytoplankton, and stress because of no oxygen, and we just haven't seen this low clear lake for kind of a long period of time too. So
there's another problem with this when you look at the data. There seems to be a well above average number of cysts after the hatch occurred.
Yeah.
That either didn't hatch or aren't alive, aren't viable. And so that number of 170 or whatever it is that you have for the end of July, or average for July.
Yeah,
it's higher now because you have an additional count that I don't have.
Right.
And I think there's also in there a large carryover of cysts, something like 50 per liter that just carried over that are in there. So, but the predictions are still off.
Yeah.
But there's something else going on there. They didn't hatch, that maybe they're not viable, whatever. But there was a big carryover of cysts.
Yeah, we were hoping they would hatch with that big rainfall that we had. We had huge flash floods and tons of rain, and we didn't see it. So
maybe
they're not viable. It could be. What do you hope? Do you hope that they're viable and they hatch soon?
No.
Or that they're just not?
I don't think you want more shrimp out
there's
there
no
with the food as low as it is.
Yeah. Yeah.
We're seeing similar patterns.
Yeah.
It's really soft.
Yeah, that,
We capture that peak in this spring.
no, I'm gonna posit that there probably wasn't one.
Really? We've
But
been talking about that.
The phytoplankton.
Yeah, we don't see that.
You don't see the phytoplankton crash.
We don't see a big drop unless our bi-weekly days happen to land really close to yours, which is possible. It doesn't leave a lot of room for a peak to come and go, but there was hardly any river inflow to the lake this year, and that might have hampered some hatching if there wasn't a freshwater lens put across it. And salinities are fairly high right now anyway, so they just may not have hatched in any number. The interpretation I have from our data is a slow crawl building up in the population where a small number of nauplii hatch, and it occurs slowly and the population slowly builds. It finally gets to a point where that first generation can start to reproduce, because we don't see substantial population until June.
Yeah, so you think that we didn't miss it,
That would be my suspicion. I mean, you'd have to line up those data sets
Right.
and see if you're missing big gaps, but we don't see anything that disagrees with yours. You'd have to look at the chlorophyll more carefully because, it's a curious bump. I don't see that in our data, but
and if we got out right after a big melt off or something and we caught some runoff, but maybe, it never really got super high. Like maybe we just got out on those 2 dates where it was higher, but if the chlorophyll, if we missed those, it could have been stayed pretty low. I don't know. It's just hard to know because we did miss like 3.5 weeks, which a lot can happen. So. Yeah, true.
This is similar to actually 2015, when our data it had a very slow population progression in 2015 as well. Very similar kind of delayed population growth that year.
2016 was that lowest year recorded, right, in the North Arm. So that was a pretty low year. Could be why.
Yeah.
It's an enigma though that the cyst count has gone up that high. If the reproduction wasn't really high, or maybe it was.
Unless they're on the beach and then the rains kicked them all.
But we didn't get a lot of precip, did we?
Or wind. I don't know. Wind could have,
Sasha, right?
or the deep brine layers turning over and cysts are coming out.
It rained in the spring. Yeah. I mean, there was definitely a higher cyst count in the spring, but it doesn't explain the cyst count going up about 300.
Are you guys getting
290
high cysts?
or whatever we had? Yeah, what's our cyst count?
It's right about 200. And we had a dip in around April, May, and that's an explicable gain that you're seeing as well. We're going to go out and see that. Those are surprisingly high numbers for this time of year. So,
But it is
Yeah.
clear that you guys didn't harvest down to 21 cysts per liter. Or
Right.
near down.
yeah, our spring counts after the season were high as well.
Yeah, looking at the data, I get us coming into the season with 72 cysts per liter is what I get from your counts.
Females.
Yeah.
Producing cysts.
between 105 and 64, and then
Yeah.
72 starts to move. So that drop in May is kind of weird.
Have you hatched the cysts that you sample?
We haven't. Yeah, we were talking about that.
They're pretty high, hatchability is pretty high right now.
But they're not hatching.
They are.
Are they hatching in the lake?
I mean, there's not nuclei.
That's what I'm talking about, in the lake. Yeah.
All right.
Well, it's an odd year.
Harvest now, or
There's no doubt about that. Is there any other questions for Ashley or anybody that's online that wants to type in a question that they have? I guess we'll provide that opportunity as well. Okay, well, so the prediction is the not prediction, and as the much anticipated thoughts there kind of go away with what we have here. So okay, if there's no other questions for Ashley, then I'll let Ryan plug in or Christine
okay.
All right.
You want to just use my computer?
update us on
Do you
nutrients.
mind if I just pull your thumb drive out here?
That's the clicker.
That's the
So
clicker to change.
you can pull that mouse. Or you could just.
Eric, can you drive? Can I get this presentation started for me?
Yeah.
So I can start talking. So, all right. So today, Christine Rumsey and I are going to tag team our update while Ashley's loading up our presentation. So, yeah, it's been a really busy time, and I feel a lot of sympathy for Laura Vernon, John Luft, and others at the state. Laura probably got the job as a Great Salt Lake. I think of her as the Great Salt Lake czar for at the worst time in history. So I feel a lot of sympathy for her. And
So wait, she's to blame.
That's pretty much what it's trained.
she got one of the worst jobs. It's just a difficult time. Anyway, okay, let's go next slide. You guys all know Christine, and she's been at several meetings now. You're getting acquainted with Christine, and we're lucky to have her. We're going to tag team this. I'll do the first half. We're going to talk about lake elevations, our inflow discharge monitoring, our inflow and lake water quality monitoring, and then the nutrient mass balance and cycling project that is ongoing. That's a picture of a technician at Bear River Bay Outflow when there was water there. That's not a recent photo at all. So next slide, please. Okay, so yesterday's lake elevation on the south arm at our salt air gauge was 4190.8. That's down almost 2 feet from our last tag meeting. And we're down about 2.4 feet from a year ago. And as you all know, there was a big press release when we exceeded the 1963 record, and then Great Salt Lake has been in the news, it seems like daily since then. If you hit the next button, there's another plot's going to show up.
Bonnie says Laura's official title is Great Salt Lake Badass.
Great Salt Lake Badass Award.
Don't type that.
I think humor is really important, by the way, and we're in a period of difficulty.
Sarcasm.
Yeah.
So we should have it on record.
Yeah, have some humor on record, because we're going to get through this here in Great Salt Lake. We're gonna get through it fine. Okay, so I have a plot now just showing the daily elevation of the Great Salt Lake Saltair Boat Harbor, now going back to October, November of 2019. And this is just to kind of illustrate the very terrible runoff we had March of 2021, May 2021, where it turns out, we got, if you look from November 2020 to May 2021, we got about 0.9 feet of rise in the lake. And the previous year we got 1.7 feet. So everybody's aware of this. It's just another illustration. But the other reason this slide is up there is just if we go back to March of 2020 and we look at how much the lake declined and where it bottomed out in November of 2020, if this year plays out like last year, we have another foot of drop ahead of us probably. That's not an official forecast. Who knows where we're going to end up? But we dropped 1, 2, almost 3 feet in the 2020 time period. We're about 1, 2 feet right now for the current year. So I think we're all aware of this. We're looking at that more drop. This rain is fantastic. And direct precip on the lake is a big deal. So this is going to help kind of maybe slow down the rate of decline, lake level decline. Next slide. Let's see what happens
that's
here.
their saline one.
Okay, yeah, if you get, so hit the back button.
Okay.
And so this is just the entire period of record of the Saltair Boat Harbor. I just put that up so everybody can keep in mind, we have a great record going all the way back to 1847. You see the 1963 low. You can't really tell where we're at there at the very far right of the plot, but we're below the record, as you all know. So next slide, please. So here's our saline gauge measuring the elevations of the north arm of Great Salt Lake. So we're looking at data that goes back to basically the last tag meeting. These are the instantaneous values. That's why the data, so those are 15-minute data points. That's why it's a little bit more noisy than some of the daily values we were just looking at for the last site. But yesterday we were at 4190.5. We're down about 1.7 feet from our last tag meeting, down about 2.3 feet from a year ago. And well, we got another historic low that we're aiming at here. So we set a new historic low in 2016 due to construction on the new breach, and that was a 4189.0. Okay, so we're at 4190.5 right now. Next, so this is just looking back to November 2019 to present, and it just gives you an idea of the increase and the seasonal increase and decreases. It's very similar to what we see at the salt hair gauge. But I think we can think about another foot, ish of decline potentially. I don't know. Things are going to get strange as we get lower and lower on the north arm, and who knows what the flow dynamics, the bidirectional flow dynamics. We don't know exactly how those flow dynamics are going to be impacted by the low lake levels. This is where some modeling and et cetera will help illuminate that. And there's the period of record for the saline gauge. It goes back to the 60s. And so to the right of the plot, you can clearly see the 2016 record low, and you have a sense where we're at today. Okay, so just to remind everybody on the inflows that come into the lake, we have continuous stream flow gauges at the Weaver River near Plain City, Farmington Bay outflow, Cog and Drain, and the old breach, which is the Great Salt Lake Breach near Lakeside. And then we do periodic flow measurements. So there's not a stream gauge. We go out and actually measure the flows with instruments at Bear River Bay outflow, and then we do that at the new breach. Those are approximately monthly. The Bear River Bay is approximately every 6 weeks, and the new breach is monthly. And we do the new breach measurements under calm conditions, so we can get an idea of just kind of average conditions. And then we all know that the flow data is very important for mass balance, et cetera, et cetera. So I showed this plot during the last tag meeting. This is the Bear River near Corinne. So this is where we have a stream gauge. On the y-axis, I have the annual flow volume, the yearly flow volume, acre feet, so the volume of water that makes it into Great Salt Lake each water year. And so I'm showing data back to 2006. That's about, 15 years of data. And then the gray dashed line at about 1.2 million acre feet is the long-term average annual amount of water that goes through past our Corinne gauge. And that spans a data record of 1915 to 2019. And I made the point at our last meeting, most of the data, the blue dots are below that, well below that average. And we have a few really nice years in 2011, 2017, where we had above average flow volumes passing that Corinne gauge. So you can see the data for 2020. We were 900,000 acre feet roughly. We're not going to be anywhere near that this year. If you hit the next button, we're going to look at the current year. So here I have the cumulative flow at the Bear River gauge near Corinne. The units are in millions of acre feet. The black line is the current water year. The orange line is the lowest observed cumulative flow at that gauge, which was in 1992. The blue line is the highest observed cumulative flow, and then the green region is the between the 25th and 75th percentiles, or roughly average range. So you see where our black line is for the current water year. If you do the conversion on that, we flattened out at that 20,000 million acre feet roughly on the cumulative flows. If we do the math, that's going to put us well down in this range in terms of acre feet. We're going to be down here. So it's going to be another bad year for Bear River Bay, or excuse me, for the Bear River Corinne.
Can't see your finger.
What?
And it's really important for everybody in the room to realize that the water that passes the Corinne gauge does not necessarily make it all the way to Great Salt Lake. This is a big deal. So, but unfortunately, we don't have a stream gauge. We've tried to do continuous gauging at this Bear River Bay outflow site on the bridge, and we have I think a year and a half of data, of continuous data that we had to really fight for to get. But now we don't have a gauge there. So we're visiting this site periodically to measure discharge. And on the data table I have here, this column are stream flow measurements in cubic feet per second. And you can see the last actual value was 959 for the recent data, 959 cubic feet per second. That was measured on April 4th of 2021. We haven't had measurable flow there since, okay? None. And we're out there at least every 6 weeks looking at that site. So even though there's water passing the Corinne gauge, it's not necessarily making it to the lake. Now, the good news is in NAF's nutrient paper that he produced in 2015, he has a regression equation where he took the continuous stream flow data that we were able to get at the bridge, and he correlated that with the continuous stream flow data at the Bear River Corinne. So there's a way we can develop an estimated record of continuous flow at the Bear River Bay outflow site. But I haven't done that here. If I did do it, it's going to tell this basically the same story. There's not been any flow basically since April at that site.
Yeah, Neil and I have flown that for surveys and we haven't seen, I mean, we have actually, the surveys are pretty easy to do because since birds don't swim in dirt, so there is no birds, no water out there, period. Yeah.
Speaking of dirt, what was the equation?
It's a regression equation. So he just developed a regression equation between the continuous flow measurements we were able to get at the Bear River Bay outflow bridge. This was many years ago when we did that for like a year, maybe a little more than a year. And so he just made a regression with that data to the Bear River Corinne. Okay.
Is that water, is it being diverted for agriculture or is it going to the wetlands?
I don't know the answer to that. There are others here who probably know. I think it's a combination.
Are you talking about where is the water diverted from the Corinne gauge
Between these two,
yeah,
bridge.
so that is where Bear River Bay, Bear River Refuge is. So that's probably about the only thing that's between there. Maybe some agricultural diversions, but for the most part, it's refuge. And they're also correct.
So speaking of dirt comment, yeah, how much that clay and soil takes to nourish itself.
Bear River Duck Club too.
Yeah, club.
Okay, so here's now a similar plot for the Weaver River near Plain City, Utah. And so annual flow volume in acre feet on the y-axis. And the average is shown with the gray dashed line. That's a period of record 1949 to 2020. And you can see most of the data for the last 15 years are below that average. Well, yeah, in some cases, well below the average. We've had 3 good years. We've been above that average, but I mean, you know, we all know this. This is why we're in the situation that we're in right now with Great Salt Lake. So next button. So here's the cumulative flows for the current water year for Weaver River near Plain City. So it's the same format plot we just looked at for the Corinne gauge. The black line's the current water year, and that's cumulative flows. And you can see we're just above the record shown by the orange line, the record low cumulative flow. That record was set in 1988. And if you do the math on convert millions of acre feet to acre feet, and, we're going to end up somewhere down here again in terms of total flow volume to the lake. Very low.
Just to add to that, the Weaver River isn't reaching Great Salt.
And there's another one right there. Yes.
All that
Continue.
water is going into agriculture or being evaporated.
So water,
Actually,
the Plain City gauge and the lake.
I think
when Ryan points to something on the screen, could somebody use a cursor to show where he's pointing on for the folks at home?
Can you see my cursor now?
Yes, please. Thank
Okay,
you.
yeah, I can do that.
So just for Ann,
Oh, yeah.
if we do the math on millions of acre feet at Plain City and convert that to acre feet, we're going to end up near the very low in terms of just total volume passing that gauge. I don't know if you can see where you're pointing on there or not, but yep, we're going to end up down in
I
that
can. Thank you so much. Very helpful.
And then the point's made, there's things happening with the water between the Plain City gauge and Great Salt Lake. So what we're showing the Plain City gauge all that water may not be reaching the lake. Okay, next slide, or next. So yeah, here we are. She's ahead of me. Goggin Drain. Again, 15 years of data shown here, total flow volumes per water year. And the gray dashed line is the average 1964 to 2020. We had some good years, 2009, 10, 11, 12, but overall, especially the more recent data, last decade-ish, we've been well below average at the Goggin Drain. And there's the cumulative flow for the Goggin Drain for this water year. The black line is this water year, and you can see we're between the lowest ever measured, shown by the orange line, and we're below the 25th percentile. So we're in the lower percentile ranking this year. And it's a similar story. If you convert millions of acre feet to acre feet, it's likely we're going to end up in the bottom quadrant in terms of total annual volume. We'll see how we shake out. This rain is fantastic. Let's have more of it. And then this is the average daily discharge values measured at our Farmington Bay outflow site. So this is really close to Antelope Island. And I have data, I'm just showing data back to January 2017, maybe a little bit before that. And there's a couple points I want to make with this plot. One is that the flows can be bidirectional at this site. So you see the 0 cubic feet in the on the y-axis, in the middle of the y-axis. So anything above that is water. So a positive discharge value is water moving from Farmington Bay into Great Salt Lake. And a negative discharge value is water moving from Great Salt Lake into Farmington Bay. So we have positive and negative flows at this site. As we go out to the current water year, you can see, first of all, the seasonal peak doesn't.
I don't know what happened. Okay.
Yeah, I don't actually. I don't have one of the cumulative flow plots.
Okay.
The Water Watch can't handle positive and negative flows to create that plot. Long story. I wrestled with that yesterday. Anyway, so we're only going to look at this plot for Farmington Bay outflow, and let's just kind of look at the seasonal trend for the current water year. So you see January 2021. We're on an upward trend. You see we reached a peak in the early spring, and then we've been on the decline. And those have all been positive. Those have all been flows from Farmington Bay to the lake. And since around April-ish, we've had very low flows from Farmington Bay into Great Salt Lake. And you can notice we don't see as many negative flows, so water from Great Salt Lake blowing into Farmington Bay outflow, and that's because the lake elevation is so low in the south arm, and it's not able to push that water into Farmington Bay. So we're not seeing as many negative flows at that site. Hopefully, the flows now kind of continue to increase. I mean, if you look at previous water years, around the July period, flows tend to start to increase at Farmington Bay outflow. So let's just hope we start to see that again. Next slide. All right. At the new breach, we do monthly flow measurements, and we've done those since December 2016. Again, those are under calm conditions. And then a side note, we're trying to experiment with a resistivity/conductivity sensor string at this site. It was developed by the hydrogeophysics branch. We did install that, but the hydrogeophysics branch is working through some technical issues to get some data out of that string. So we're not getting data yet. We hope the string is going to accurately identify the depth of the boundary between north and south arm water at the new breach. That's important for figuring out cross-sectional areas and for computing a continuous discharge record. That's the next point. We need that data to help us improve continuous flow computations. And we're also working a lot with the USU group that's doing the modeling at this site. We have meetings with them basically weekly or every 2 weeks. We coordinate our field work with them. We're doing everything we can to help them with their modeling effort. Next slide. So here's our monthly discharge measurements of the new breach, showing the entire period record back to 2016. The blue circles are discharge values for water moving south to north. The red circles are north to south flows. They're bidirectional flow at the site. The gray line is the head at the breach. And that's calculated actually using the saline gauge and the salt air gauge. The most recent measurements were made at the beginning of this month, August 5th. So we measured 1,070 CFS moving from south to north. We measured 299 CFS going from north to south. And if you look at the plot, most of the time, there's a lot more flow going from south to north. So we have a net loss of water to the north arm at this site now, and that's typically it's that way. There's nice seasonal fluctuations you see in the historic data. When the head difference gets high, you see the more flow going from south to north. But if you look at from October 1st, 2020 outward, you see the seasonal signals very muted this year. The head difference didn't really change a whole heck of a lot. So the seasonal signal is muted. But thank goodness we have this data right here to help us understand something about these flows at this site.
Brian?
Yep.
The north to south always a third-ish less than the south to north, or is that unusual for this time of year?
No, the flows definitely vary, and there's times where it's not a third, right? There's times when they're almost equal back and forth. So it's definitely there's a seasonal component to this. So I would not say maybe it's typical for July if we went back and hunted and pecked through the data, but I haven't done that, so I can't answer that in the affirmative. But here's the data. We can take our time to do this if we want. But okay, I'm going to hand over to Christine.
Cool. We had one question in the chat. Jamie Butler was asking, with that elevation drop in the south arm, is there a prediction on what the salinity will be by October?
We're not going to predict, but Christine's going to show the data, and we can all look at the data and see the trend.
Okay.
So that's coming up. There'll be a slide on that.
Craig Miller asked, is there an elevation measurement at the bridge now?
Yes.
Okay.
Yes. We have lake elevation gauges now on the causeway, one measuring the north arm, one measuring the south arm. So we can do very accurate head measurements at the causeway rather than using the saline and salt air gauges. The reason that's what I've done in that plot is the gauges on the breach, those are relatively new. So I wouldn't be able to show heads going all the way back to 2016.
Can we look at that?
Yeah, that's all this data. Everything I've shown you is available on INWIS. And use INWIS Mapper. That's the easiest way. That's a map of the lake, and you zoom in and you click on your sites. It's all there.
Great. So now we'll jump into nutrient stuff. Ryan went through all the stream flows of these inflow sites that are shown on the map. And now, we also collect nutrients while we're there measuring discharge. So Bear River Bay, Weaver River, Farmington Bay, and Goggin, we collect phosphorus, nitrogen, and their species. We do that every 6 weeks. And we have quite a long record information. And did you want to talk about that?
Yeah, so Dave Nass, he decided to just continue paddling that boat, and he is retired from working on anything for the Utah Water Science Center. So we've had to move his nutrient mass balance paper that we owe the state to John Solder. He's a research hydrologist at our Water Science Center here in Utah. John is an extraordinarily talented hydrologist. And so he is working on this now, and he's been communicating with Dave Nass. And so this work is ongoing, just so that you know. And I'm going to keep this slide in here. We're going to keep looking at it until this report's done. So,
Ryan, you said John
Solder. Did I say John left? Sorry, John Solder.
Oh, it's up there. Oh, okay.
John Solder. Yeah.
I just didn't want to spell it.
Not working. Okay, cool.
Okay, and we also partner with the Great Salt Lake Ecosystem Program to collect nutrients at 2 sites that are shallow. The 2267 and 2767 are shallow sites, and then we have deep sites at 2565 and 3510 where we can collect the deep brine their information as well. And so samples are collected every month, and we measure nutrients and density at these sites. And so, as Ryan said, we want to take a look at densities, aka salinity, and how it's behaving. So at these two deep sites, one in Carrington Bay and one in Gilbert Bay, we're plotting densities over time. For the little triangles represent shallow data for shallow water, and then the circles filled in represent deep water. And then the green is in Carrington Bay and the blue is for Gilbert Bay. And so you can see, do you mind being the pointer on this?
Totally.
You can see when lake levels, well, now they're dropping, as we all know. Density is going up both for the upper brine and the deep brine. And let's see, so I guess we had a little uptick during spring runoff, and we saw a little dilution of densities then, but really it's just trending upward over time. And if we look at the density converted to salinity concentrations in grams per liter, you can just see again how these values are trending up. In fact, at the deep sites, for the deep brine layer, the equation of state no longer, we can no longer use it there. The densities are so high that they're out of range for the current calibrated equation of state. So that's why those values tend to drop off. But yeah, you can see salinity is increasing. I think at this most recent measurement on July 29th, it was about 155 grams per liter is what this salinity was.
And it looks like back in 2017, were we somewhere near there, the peak or close to it?
Yeah, it doesn't look like it. So yeah, when there was no flow from the north, the upper brine and the deep brine mixed, and we did observe where those upper brine salinities increased as well. And then yeah, kind of headed back in that direction, even though there is still a deep brine. And then looking at nutrients, as I said, we collect these every month. So the plot on the top is looking at total phosphorus, on the bottom at total nitrogen. So this is data updated through June of this year. And you can just see what's really striking about nutrients when I look at these total species, total nitrogen, total phosphorus, is just how incredibly consistent they are over time for the shallow. So sorry, this is the shallow. These light blue, that's shallow water, and then the dark blue is deep water. So really consistent concentrations over time for both for phosphorus and nitrogen, but there is quite a bit of variability in the deep brine layer. And these shaded areas indicate when we do have a deep brine layer present. So from kind of mid 2014 through the end of 2016, the deep brine layer disappeared, they mixed, and the nutrient concentrations at both shallow and deep depths are basically the same. The deep brine layer, as we've said before, really plays a role in what nutrients are doing. It's trapping it, or it might be interacting with the sediments in a way that is encouraging the release of nutrients from the bottom sediment. We're not really sure at this point, but deep brine layer is definitely playing a role, and you can see the increase in variability in those concentrations there. So this is for the site in Carrington Bay. And then if we go to the site at Gilbert Bay, very similar patterns, increases in both total phosphorus and nitrogen for the deep site. And of course, when the deep brine layer is present, we see those same patterns. So now I'll just give a brief update on this study that we were funded to complete, where we're looking at quantifying nutrient mass and internal cycling in Great Salt Lake. It's really fun for me to hear Ashley and all of you talk about brine shrimp and chlorophyll A patterns and what's driving the production in the ecosystem, because this is kind of what when we're looking at nutrients, this is like the end goal of what we're trying to accomplish, is to inform what you're doing here. By meeting these main objectives, which are quantifying nutrient mass from multiple pools. So basically, where are nutrients in the system? Kind of getting an inventory of just where they are. Are they in the sediment? Are they in the deep brine, the upper brine, or are they in the biota? Just getting a better sense of that distribution. We also want to try and estimate nutrient flux rates. So, how are nutrients being deposited to the sediments? How are they undergoing chemical transformations and maybe mixing back into the upper brine where it's bioavailable? Or are they being removed through volatilization or through being sequestered in the sediment? These are the types of questions we're trying to get at with this study. And I'm happy to be more, elaborate more. I just feel like folks have heard this before and I don't want to bore everyone. But yeah, basically we're trying to figure out what is controlling nutrient processes in the lake. So right now we're working on a data release, and that's USGS speak for making all of the data publicly available on the web. So all the samples we collected last summer, last August, I think we have, we generated 1,000 new data points, and we're putting that all into a data release that anyone can access and conduct their own investigation if they so choose with that data. We're currently on track with the interpretive report. We have a pretty solid roadmap of where we're headed and what is going to be included in that. But the interpretation is ongoing with that, and there's kind of a lot to sort through. So the data release, this is just an example of what that will look like on the USGS Science Base. It'll have, a landing page, and then there will be a series of files attached to it where you'll be able to access all the tables with data. And the tables will include all these different kinds of sample types. So we sampled water, we collected material that settled out of the water column and sediment traps. We collected material at the sediment water interface at the bottom of the lake, bed sediment itself. We did a number of measurements on the bulk density of sediment, so trying to figure out its porosity, its density, the characteristics of the sediment. We collected ceston or phytoplankton. This is actually our most problematic sample right now. We worked with Georgia State for them to process these using an ultracentrifugation technique, and they got bogged down with COVID. So they were, Georgia asked them to start COVID testing, and so they've been way behind. And so we actually don't even have these samples yet. And so these samples are kind of holding up this whole data release because we just don't have them. So it's kind of the reality of what we're working with right now. We collected brine shrimp, analyzed nutrients in those. Of course, we have river inflows. We collected material deposited through the atmosphere to try and get an estimate of atmospheric deposition loads of nutrients to the lake. We have water quality profiles, links, all of our QA/QC. So all of that will be included for the public to access. And in terms of interpretation, I'm really in it right now and not quite ready to share much because it's kind of jumbled in my head right now, but we're working on it, and it's going to be, I think we're going to learn some pretty neat stuff. For folks who were at the advisory council meeting, I shared this preliminary result, which was answering one of our main questions of the effort, which is where are nutrients held in the system? And so I'm just showing an example from 2 sites in Gilbert Bay, what we call 3510 in kind of the center of Gilbert Bay, and GB14 in the southeast corner of the lake. And how we're sort of conceptualizing this is to say, okay, we're going to a certain site. Let's say we take a square meter from the surface and we just move downward through the lake. So moving down through the upper brine, where we have brine shrimp, moving through the deep brine, and then the sediment. And so let's quantify the mass of nutrients in that volume of each of those pools. And so that's what I'm showing in this kind of bar plot here. So on the y-axis, there's the mass of nitrogen. We're looking at nitrogen in this case for each of these pools or reservoirs for these 2 sites. And what kind of just jumps out immediately is how much nutrients are held in the sediment. And this is, we're just calculating it for the top 1 centimeter. And so just putting kind of the water column concentrations and mass in in a greater context of like all of the things happening in the lake. So we have maybe 20% in the case of 3510, 20% of the nitrogen mass held in the water column. The mass in brine shrimp is really negligible, and just very, very small amounts of nitrogen held in the biota. When we get the ceston results, that will be another component here. So we'll see what's in there, but I anticipate that will be very low as well. There's not much held in the pore water, and pore water is that interstitial water in the sediment. So you can imagine that is a very small mass. There's just not much water there to begin with. So really just so much in the sediment. I mean, it's there, and then it's all about what chemical processes are happening at that sediment water interface that will release it back into the water column or not. That might just remove it from the system. But now we kind of have a better sense of kind of where nutrients are. I mean, at GB14, it's a little bit of a different story. There are more nutrient, or there is more nitrogen in the water column compared to 3510. And so this is something else we're curious about, is why are these differences occurring? Is it sediment, sediment type, maybe sand versus a clay, et cetera? Or is it some condition with the deep brine? Could it be that at GB14, we get a lot of adductive mixing along, kind of more along the shoreline, and maybe it's just mixing more there into the water column? So these are the kinds of questions, we're starting to play with and ask. And of course, we also quantify this for both phosphorus and organic carbon. So you can kind of see how those behave as well. Phosphorus, they're very consistent between these two sites. A ton of phosphorus held in the sediments, and relatively the same amount we're estimating. Organic carbon tends to resemble patterns we saw for nitrogen. So this is, just very preliminary. What we're working on now. Right now, I'm trying to dig into the flux rates a little bit more, so we can get a better understanding of how things are moving. Now that we have a better sense of how they're distributed, now trying to move into how nutrients are moving through the system. So that's kind of where we are right now. Any questions?
Is there any questions for Christine or Ryan? Or any online? Yeah.
Christine, were you expecting the sediments that have such high nutrient content?
Yes, I think I was, but I was really curious. I was really curious to see the rate of deposition and what we might expect to be there based on what we are actually settling, and comparing that to what we're going to estimate is being buried and sequestered. So we can get an estimate of how much is actually being recycled. Does that make sense?
Yeah.
So by comparing those two rates. And so that's what I'm really excited, and I wanted to share, but it's not quite ready. But I did expect there to be a huge amount of nutrients, just because we know there's so much organic material settling to the bottom. We know it's there. So how much is the system processing it? And how I'm also really interested to see how the deep brine layer versus not deep brine layer affects that, because it seems like, the conditions in the deep brine, it's anoxic, hypersaline, there's a ton of nutrients there. Can we observe, is there evidence that it's playing a role in recycling that more efficiently than without the deep brine?
If you look at your graph, the one graph you had where you're looking at the history of total nitrogen in the upper brine layer, it seemed like it was relatively stable. There may have been a slight trend of having a little bit more during the period of time that the DBL was gone. Did you ever look at if there's actually a significant differences in the upper brine layer?
They are higher, and I can't remember if I did it, but I'll check that. If you're interested, I can email you, because that'd be a relatively
it'd be interesting to find out. It doesn't look like it was very much.
But yeah.
But it looked like it was a little higher.
Yeah, I'd be happy to. I'm trying. And I mean, it's kind of just a mass balance problem. So if you have, deep brine and upper brine super concentrated in the deep brine and they mix, you would expect those concentrations to go up. We see that with salinity as well. If we do, if we predict salinity mixing, if there is no deep brine, the upper brine salinities increase. So it's just kind of a, you'd expect it to happen. By how much, and if that's significant, I don't know. Because it also matters about the form. I mean, I was showing total nitrogen, but really I think what we think of as being bioavailable is inorganic nitrogen, which is very low in the upper brine and very high in the deep brine. So, and when we talk about bioavailability, that form really matters.
Anything else? All right, well, let's get a update on the model that Gary's working on.
Okay, it's great to be at least with some of you face to face for a change, and hopefully get some better interaction than we've been able to do over Zoom virtually in the past. Okay, as Ashley pointed out, we're dealing with a changing environment, and a lot of you now are news famous, constantly being interviewed on things. But anyway, the temperature, as Ashley pointed out, hasn't changed a whole lot. It's a little warmer, but not a lot. The big difference is we compare 2015 through 2020 with this summer, the salinity's gone way up. And so we can ask, what are the phytoplankton responses we've seen? Ashley pointed out that the chlorophyll values have been rather strange this year, extreme ups and downs, and the 2015 to 2020 average here is in red. with standard errors, but they're not significantly different because there's huge variability in the years. If we look at the composition of the phytoplankton from the counts that we do for the state, you can see that the chlorophytes, Denaliella in particular, is higher than normal over that period. And the diatoms, bacillariophytes, have dropped much lower than past years. And the cyanophytes have gotten much higher. But these are not major differences because if you again look at the variability over that period from 2015 through 2020, there's huge variability on an annual basis. And what we're seeing this year is pretty much within that variation. And if you look at the comparison of the average values for through July of this year through July in past years, there's virtually no difference. If you notice, this is a log scale, so I can plot everything together. There's no big difference in the composition of the phytoplankton over time. So we're not seeing much of an effect here of these changing environmental conditions on the phytoplankton. However, we have seen, as Ashley pointed out, huge variation in terms of the brine shrimp dynamics. The red again is the average 2015 through 2020, and you can see that average of shrimp, number of shrimp per liter, they came much later this year than in most years. And now we're not off from what we expected this time of the year, but we had this whole period early on where we didn't see many shrimp. If we convert the number of shrimp to biomass, and I do that in terms of adult equivalents, you can see the same pattern. We're actually slightly more biomass for this time of year now, but we missed out that whole spring period of shrimp. If we look at the amount of food per adult equivalent, we had plenty of food in the spring to begin with, and then it's dropped below where we normally see on the average. And as we all know from Gary should be brave enough, thank you, that would have been Bonnie. As we all know, it's when food is in short supply per adult that we see the shift to the cyst production. And we've demonstrated that in the lake, and we demonstrated in laboratory experiments as well. And look what, as Ashley pointed out, to remind you, the cyst production is way up over what it normally is at this time of the year. I'm going to come back to this because I'm going to ask, can the model predict what we're seeing per year for this year? And I don't mean the harvest model projection. This is the ecosystem model. It stopped changing.
Let's see, can I do it?
Now you've got it off presentation mode.
Let me click on. I'll just click for you.
Okay. So the next step is to point out that our laboratory experiments on which the ecosystem model is based, 2 of the manuscripts are ready to be submitted. John has copies of them with all the raw data in them as well. One is on phytoplankton growth, which is growth of a Denaliella, a diatom, and a cyano bacteria. And that's 495 populations that have been monitored over time. We have the shrimp demography down, each life stage, different temperature, all of these are different temperatures, salinities, nutrient levels, etc. And that's 4,305 populations of brine shrimp that have been monitored over time to get survivorship, growth, reproductive output, transition from one stage to the next, and then the offspring monitored of the mothers raised under those conditions. So we have all this information. It's now ready to be submitted for publication, and John has those manuscripts. Oops. See.
Is it working?
Let me see. Yeah, it's
Okay.
working again. Okay, another experiment that we're not quite done with. Andrea, my technician here, we're still in the process of working on this, but that's to look at feeding preferences. And we've looked at it, giving them the rate, measuring the rate at which they can ingest different foods. Again, a chlorophyte, Deniliella, a Bacillarian phyte, common Bacillarian phyte from the lake, the diatom, Nitsia, and a common cyanophyte, Euhalothaceae. So we've looked at how fast they can ingest these different foods when you give them that food alone. We've given them the foods in pairs to see which one they eat more of if you give them the food in pairs. And now we're in the process of doing all three foods together. And the interesting thing here is that prior work with brine shrimp argued that brine shrimp could not discriminate between foods and they just randomly ate whatever was in the water column. They're actively selecting ingestion of particular foods, and in particular, in most cases, they're preferring Deniliella. So they're far more complex than a lot of people have thought. Stopped again. Actually, what are you doing?
Nothing.
No, it stopped. Okay, so now let's get to the ecosystem model. And we're dealing with the pelagic part of the lake. We haven't started building the model on the benthic portion of the lake. But in the pelagic portion of the lake, we have abiotic module. And I'll go over each of these for you. We have a phytoplankton module, brine shrimp module, a grebe or bird module, and then there's a module that integrates all the solutions, output of the model, and plots them. Go ahead. Okay, in the abiotic portion of the model, we have that subroutine has modules that deal with climate, which is an input that you put in, hydrology, which takes various flows within the surrounding areas of the lake and changes the volume of the lake based upon Rob Baskin's calculations. But given these inflows, it's then taking what the lake was last year, this year, and what it'll be the next year. And with that, then it affects the salinity, where there's a dilution of the water to get a salinity of the water. And it affects the nitrogen availability, where there's some base nitrogen. And that affects the nitrogen value from June to December, and then affects the nitrogen value from January to April. And then for all these calculations are done weekly. That affects the nitrogen value that's available for that week for the phytoplankton to use. Now, this is the part I'm going to come back to later because John has asked for a more detailed nitrogen portion to the model, and I'm going to talk about that later. Then we get to the phytoplankton routine, and that's the most complicated routine. And we have the growth of the different phytoplankton types. The chlorophytes in green, blue is the cyanophytes, and the brown here is for the Bacillariophytes, the diatoms. This is the data from those growth experiments of the different types of phytoplankton that we just finished the manuscript on. This breaks this all down. Each of them grows, and you have a different amount in the lake on a weekly basis. That amount of growth, and that is still there, or had been there prior, is now reduced by the grazing of the brine shrimp. And that takes in the grazing rates, those single species of phytoplankton with the brine shrimp of each stage, how fast they can eat it. That's taken in there. And then another subroutine deals with how it is taken up in more detail. This is an average value here, but this breaks it down to how much they're getting on a weekly basis with the feeding preferences built into it. So all very complicated. It's not complicated. It's just a lot of detail that has to be taken into account to get their feeding. This grazing then is reduced from the growth and the standing crop of the phytoplankton that are there for that week. Next. Next. Then we have the shrimp population subroutine. And we have the population of shrimp here of each age category, stage, developmental stage. We have the demography, how they're surviving, how fast they're growing, how fast they're reproducing. And this goes back into the number of cysts that are being produced, number of live young being produced, and the harvest is taken off of those cysts. There's this harvest subroutine as well. This is the demography population lab experiments that we've done. That's what controls this. Then we have the grazing rates from the phytoplankton subroutine coming in and saying how much food do you get and how well do you do on each of those foods. That goes into this population routine. And then there's a cyst overwintering routine from previous work we published from when we put cysts out in the lake over the winter and monitored their survival over the winter. And this is built in, including the effects of salinity, temperature, and a very important factor, which is the mother's nutrition when she made the cyst. So there's a very strong maternal effect here. So if mom didn't have a lot of food and she's producing cysts, they don't survive well. Now it's working again. Okay, then there is a grebe subroutine. And this is my Conover's group's data on grebe feeding and all that built into this here. And now the calculations change. The calculations, everything up to this point, the calculations are on a per liter of lake value. Grebes don't care about a liter of water. Grebes are concerned with what's out there in the lake in total. So you got to take that liter values and multiply it now times the volume of the lake to get a total food resource for the grebes. So this, we'll come back to this in a minute, because that's where current conditions now start coming in, volume changes. Okay, how good is the model? Our last virtual meeting, somebody asked the question, well, are these predictions from the model statistically good? Are they different? Are you reliable? Well, here's the chlorophyll predictions from the model. The R value, these are monthly values predicted for the model from 2015 to 2020 versus the observed chlorophyll value, R of 0.95. We're pretty good. We look at the annual values predicting, this is chlorophyll average for the year, real good. Chlorophyte percentage abundance average for the year, pretty good. Bacillariophyte, diatom, and then we got a little difference there. But if you notice, this is logarithmic again. So that difference there is like only 2 percentage points. Off a little bit on the cyano, the difference there is about 3 percentage points. Adult equivalence, this is the peak biomass of shrimp in the lake, pretty good prediction. And this is the peak cyst production or standing crop of cysts in the lake for each year, and it's right on. So the model's doing pretty good on an annual basis. It's doing good on a monthly basis for chlorophyll. And here's the predicted adult equivalence on or biomass of shrimp on a monthly basis. It doesn't do poorly, but it's not as good as we might like. It's an R of 0.88. So the model's not doing badly. Where it starts falling apart is if we look at the chlorophyll, not chlorophyll, the percentage of phytoplankton predicted to be chlorophytes, cyanophytes versus bacillariophytes. And let me point out here, you can see the red is observed since 2015 to 2020. The blue is the model prediction. So for the chlorophytes, you can see here, they're predicted to be much more abundant, 95% versus 100% in the winter months. And they're actually much lower than that. They're about 96%. So all of these differences are less than 5 percentage points. I'm not worried about that. But given the amount of data we have, they are statistically different. Okay, 5 percentage points is not much when you're dealing with a large scale model like this. We're way off on the cyanophytes. They die off way too much in the winter time. In the summer, they're doing okay, but they're dying off in the winter time too much. Same thing for the bacillariophytes. Phytes. The model has them dying way back too much in the winter time and not responding enough in the summertime. But if you notice here, we're dealing with 1% to 7%, and here we're dealing with 3%, one little less than 1% here to 10% tops. So they're not big differences we're dealing with here. The reason I think this is going on is that those experiments we did with the different types of phytoplankton, the model is built now by just running a straight line through the data. I think what's going on is that the colder temperatures of winter, those numbers, instead of going linearly down, are starting to flatten out. So we need now to take that data and put some sort of curvilinear function to it. I think that's going to take care of these winter responses there. So we're doing, I think, really well. Now the model also, as I pointed out to you in the past, has a game player module on it. So somebody can take this model, and there's a dashboard that it gives you. And the dashboard allows you to set different parameters for the model. And then it'll run the model and do the phytoplankton calculations, bird calculations, brine shrimp calculations, give you the nitrogen, salinity, etc. You then can go to the next year, and it gives you a new dashboard of saying, okay, what could have changed from last year? Now, you're not going to change the shrimp because you're stuck with the shrimp from the previous year, but you could change temperature. You could change water inflows, all of these annual variabilities that are non-biological. You could change the harvest. So you can tell the harvesters take more this year. I'm not going to say take less because you'll yell at me for that one, but I'm going to say take more this year.
Yell at you.
But anyway, so you can vary these things and then have it give you another year's prediction. You can go back and do this again. It'll allow you to do it for 5 years in a row. I don't want to go more than 5 years because things could really change a lot in your baseline values over a 5-year period. So it's restricted to 5-year projections. Okay, now we're to the news media. Dwindling Great Salt Lake. There's two things we got to think about here. And unfortunately, we oftentimes deal with only one, and that's the volume issue of the lake. So that volume issue has to be multiplied times the biology per liter to give you the total effect. And the biology per liter is what the model here is working on. So from Rob Baskin's volume to lake level values, tell me if this is right. I calculate the 2015 to 2020 volume versus the end of July this year, that the lake has dropped about 14% in volume. Is that about right?
I can't answer that.
Okay.
Sounds reasonable.
Okay. And the reason is it's a dish. And so you're losing the edges. So you lose a lot of elevation, but you're not losing necessarily a lot of the volume yet. Yeah, that's what I'm stipulating here. So what we focused about today and what we've seen in the news is dealing with this volume aspect here. is there an effect going on the biology? That's what I want to ask. And we can use the model to ask that question. Well, I never thought I'd have to use this again after we started doing the projections for the harvest, but we're doing some guesswork here. And when I went to the model and asked if I put in this year's salinity change, this year's temperature values, so we use that as the input, I realized all of a sudden we had another thing going on that we had to take into account biologically. And that was how many spring cysts did we start the year with? And this year we started with, as we talked about already, many more cysts coming in than with the 21 per liter that we are striving for. Here's the predictions. Let's just go to here. The chlorophyll A is way off. It's much, the green bar here is way lower. That's the observed now. And all the other bars, red here is, if we had 21 cysts coming in the spring versus 72 cysts coming in the spring, that's what you would expect under this year's values. And this is if we had the 2015 to 2020 values, not the increased salinity and higher temperatures. We should see no effect on chlorophyll. For some reason, our chlorophyll is way down. Okay. Let's look at cyst production though. If we came in with 21 cysts per liter with the current conditions, and we had 21 cysts per liter under the past conditions of the lake, the red bar, the kind of, what is that, purplish pink color, and the light blue values there, they're real similar. If we had 21 cysts per liter coming in the spring, we'd see no effect. We came in with 72. Look at the blue bar and the green bar.
Very close.
Very close. So the model seems to be working in terms of the biggest difference that we're seeing, which is cysts per liter. We came in with too many cysts per liter. And you might say, well, look, we got more cysts now, even though we came in and we're predicting far less. Let's take the model now more than 1 year into the future. Don't harvest 21 cysts per liter next year. Let it continue to run. Domino effect, 30% decline in cysts if you don't harvest 21 cysts per liter for next year. The system starts to decay. And that's what I told you was my guess was going to happen in these situations. It's not just this year, next year, you're going to see lower cyst production if you don't harvest 21 per liter this winter. There's a carryover effect here. And so this is what I'm afraid of.
Why would the chlorophyll be so low?
I can't answer that. I wish I could answer that.
Yeah.
What's the salt tolerance of the
They love high salt. That's not it. It's the diatom and the cyanos that suffer from high salinities. But they love high temperatures. Okay, so the diatom and the cyano like high temperatures that when we reared them. The Denaliella hates high temperatures, but loves high salinity.
Larry, do I remember correctly that the high salinity threshold that you use in a lot of the lab experiments that feed into this model was 150?
Yeah, so we're low on those projections.
So are we concerned about that? Is that something we need to look at as we're in this? And
yeah, I don't think John wants me to do more experiments at higher salinities.
Well, he may not.
And I would argue
we may need to.
We may need to. And the other thing we're missing is colder temperatures. We dropped everything off at 10 degrees centigrade. We may need to go to near zero.
Yeah. Yeah, I think
that's where we're missing the information. But we chose those values
Yeah, based
given the
on,
past.
yeah, no, it made perfect sense, but I'm thinking, looking into the future.
Yeah.
As we're, in that, sort of threshold range of salinity, we should probably take a look at that.
The phytoplankton values go to 150, the shrimp values go to 120 only. Because what we did was we looked at the shrimp till we saw them peak at some value, and then we saw them at the next higher salinity go down. And that's when we truncated the salinity to look at, because we were looking at what they perform best under.
Me, if I look at sort of the odd year that we have today, and it could be a, one-time deal, but it could be that at these higher salinities, the whole population is really reacting somewhat different from our expectations. And that may be because we haven't studied it.
It's possible. I can't answer that. I mean, I can talk about, all I can do is make the projections on a curve that we know goes up and then starts coming down, and then extrapolating onward from that downward.
I'm still a little bit confused and don't quite understand how in the harvest model, you're predicting a really low cyst count and we have a much higher cyst count. Whereas then in this model, you're telling us, well, it's not this year we need to worry about, it's next year.
Well, part of the reason for that
entirely.
Yeah, for part of the reason for that is that cyst model for harvesting, when it was built, was very, very different conditions in the lake. We were running at that point, 90 ppt to 12, 13 ppt. We're in much higher salinities now than at that point. And temperature has definitely gone up over that time period as well.
Yeah, I wonder how important temperature is here.
Temperature, I think, is more important than the salinity.
Maybe it is. Well, salinity is important too.
Yeah, but in our lab experiments, we get stronger response to temperature than we do to salinity. But there's a strong interaction term between salinity and temperature.
Yeah, that's true. But if you look at the literature, the population level effects from salinity really start to happen around that 160 ppt.
And we haven't gone to look at that because we didn't expect that we would be over in there. I agree.
Well, that's why it's an adaptive management system.
Yeah. Yeah. So I think, as I pointed out with the phytoplankton, I think at those cold temperatures, instead of coming down like this, it's tailing off.
Yeah.
I think on the same case with higher salinities, instead of us seeing it continually rise, or rise and then fall, it may be falling all of a sudden much more precipitously than we're predicting.
Well, and the interactions between temperature and salinity and the population level effects on reproduction, could maybe explain partially why we're seeing this high cyst count / eventually high cyst production.
Let me just also point out, if you have an interaction between temperature and salinity and the model, I'm being honest with you on how the model is being built at this point. With a straight line, there's no interaction now between temperature and salinity. It's temperature as one variable, salinity as one variable. There's no interaction between the two. That can be built in.
Yeah.
Is there an interaction between chlorophyll in the lake and inputs from the rivers?
Yes.
Okay.
It's not direct. It's how that changes the nitrogen levels in the lake and salinity levels in the lake, feeding back on phytoplankton production.
Okay. I was
So
just wondering if
it's not direct. It's not direct. It's through nutrients and salinity.
But would that at all affect the prediction for chlorophyll being higher? Because like some of the rivers aren't even reaching the lake, and that could be the source of chlorophyll.
Now, they're playing the way this model is built under its assumptions. The assumption is there's very little nitrogen coming in from the water around it. Or it's the same amount coming in that's going up into the atmosphere.
Okay.
The model is built that there is a pool of nitrogen in the lake and a pool of salinity, salt, and it's just being diluted.
Okay.
Or concentrated.
Gotcha.
Gotcha. And that's one of the things, as the lake volume goes down, the nitrogen per liter goes up.
But does the bioavailable nitrogen go up? I mean, we've seen some lakes in different parts of the world where, you know, the population density is so much higher than what we see here. And most likely as a result of the, you know, the available nutrients.
All of the calculations here that I'm making in terms of nitrogen are based on inorganic forms of ammonium and nitrate, etc.
I think it points out again that the work that USGS is doing right now in, you know, the work in terms of the cycling and the bioavailability of nutrients is really important, you know, in trying to explain what may happen as a lake volume decreases or increases. Because clearly there's a huge pool of nutrients available. I mean, that top, is it 1 centimeter?
Yes.
And then in the GBL, the question is, how does it become available or not to the population?
Well, let me go on then, because there's new module being added to this. It's not working again.
There was a question from Jeff.
Yeah.
Are you estimating salinity as one value?
At this point, there's only one salinity.
Okay.
I'm coming to that as well.
Is it the entire depth or?
It's the entire depth. There's no variation with depth in this. Okay, so I was asked to modify the abiotic submodule to bring in more detailed nitrogen dynamics. There's a biotic effect on the budget. Now, all these calculations are per week because all the biology is happening very quickly. So we've got uptake of nitrogen by the phytoplankton up there, uptake of nitrogen by the brine shrimp here, uptake by the birds. We've got temperature and salinity playing into all of this. I'll come back to this in a moment. And then this feeds into how much into this nitrogen distribution in the water. And it actually feeds into this base nitrogen value. You can see phyto effect, shrimp effect, bird effect. Here's the base nitrogen value. That value now is diluted by the water, the hydrology aspect of this, but it has to now be apportioned to, here's the hydrology, has to be apportioned to how much goes to the deep brine layer and how much actually goes into the upper portion above the deep brine layer. And I'll describe this in a minute, but so there's two modules in this. Let's see if it works. Nope. Okay, let's look at the biotic here, and I'm only going to do one biotic aspect because it's the best data that we have available right now. And that's for the shrimp module. Shrimp eating phytoplankton. The effect is neutral because that nitrogen already is in the phytoplankton. It's out of the water. So that's neutral. And so this takes into account phytoplankton grays times the nitrogen content. That tells you how much is just being transferred to the shrimp. But some of that is not processed, it's excreted by the shrimp. Adult equivalents per liter times 0.019 milligrams of nitrogen per adult equivalent per week. Okay, not measurement from me, that's found in the literature. Population growth of the shrimp, neutral, because it already was in the phytoplankton. But you can calculate what that should be by the nitrogen content of an adult equivalent. Population decline, that adds to the water in the water column because they're dying and decomposing. Adults equivalent dying times their nutrient content times a rate of decomposition of 0.33% or a proportion of 0.33 release per week. Experiment, new experiment. Andrea has been pulling her hair out. We're trying to get this to work where we're taking lake water with lake bacteria set at a temperature and a certain salinity and seeing how quickly the brine shrimp decompose.
Nice.
So here's the most recent pilot experiment that we did. Ran 12 days, and over that 12-day period, we got down to something like 60% of the mass of the shrimp was lost in 12 days. If you carry it out, it takes 3 weeks to decompose completely. That was done at 20 degrees centigrade and 149 ppt. So this needs to be done now at other temperatures, other salinities. This needs to be redone as well. This was a pilot shot, but that gets you to about 1/3 of the nitrogen should be released per week. Yeah.
This is done under oxic conditions.
Oxic, yes. We do have deep brine layer water that we can do it under anoxic conditions with those bacteria as well. But right now we're at a stage of just trying to get the methodology done. Yeah. I suppose we have to at some point. Right now, what we need to know too is how fast does this stuff settle out into the sediments? And then what is that rate down there? So it's a lot more complicated than what we're at right now, but I'm just trying to show you the type of information we need because the biology is operating on a weekly basis. Actually, it's operating on a daily basis. We've averaged it out to a week. Okay, then we have cis produced. That's neutral because that nitrogen's already been taken out of the phytoplankton. So that's not going to add anything. Harvesting, that's a loss of nitrogen. That's nitrogen taken by the cis and being removed from the lake. And here's the value for nitrogen per gram of cis. And then we get bird consumption of the shrimp, and that's neutral because that nitrogen has already been partitioned out of the system. Now, of course, the birds are going to excrete some of the nitrogen that would add back. Birds are going to die. They got to decompose. So we're going to take some chicken, and throw it in now and see how quickly it's released. But the feathers decompose. As Mike's students have pointed out, feathers are a really important thing in the lake in terms of nitrogen budget. So that has to be included in there. And we do have some literature values on how fast feathers decompose. So we can make some preliminary estimates there. This all has to be done for the phytoplankton as well. So instead of putting in dead shrimp, we'll put in dead phytoplankton. So that's that aspect of the model. Now it's working again. Okay, then that feeds in to this base nitrogen value. And we guess a portion then to the deep brine layer versus the brine, the upper above the deep brine layer. And using the USGS data, we came up with a point of salinity where it becomes equal versus becomes sequestered in the deep brine layer. And that's at 120 ppt. That's averaging from all those nitrogen deep brine layer values versus above. Okay, and then a proportion of it when the deep brine layer, when the salinity of the lake goes above 120 ppt, a proportion of it will be released from the deep brine layer back up into the upper layer. And that is from some of the column studies that Wayne Wurzbach's PhD student did. So a lot of this we don't have the numbers for right now, but this is what the model needs to keep it on the same time scale as biology going on. Okay, any questions on that? And when, yeah.
Is there a way for you to know which inputs affect your output the most?
Oh, I can do sensitivity analysis once the model's done.
I'm just wondering if you're running this at a weekly time step and we're collecting data at a monthly time step, is there something we can collect weekly that would help improve your estimates, or you think your
Yeah,
estimates are?
I
good
can
enough
do that, but the problem I have right now is I don't have the numbers to be able to make that type of prediction at this point in time. I'm sorry.
Yeah, okay, but if we did the sensitivity analysis, you could identify which parameters might be
Yes,
worth collecting.
yes, I can do that.
Would it be helpful to know the amount of like detritus that's on the shore that could be in the lake?
You know, that's a possibility. It's not included at this point in time. There's all kinds of things we can think about including at this point in time. I'm trying to keep it as simple as I can at this stage of the game. Right now, to even get these numbers that I'm showing you right now for like the brine shrimp and that, I'm digging through some really, really obscure journals. I mean, thank God for Google. You know, I'm not kidding you. I mean, if I had to find this stuff by just going to the library and letting my fingers do the walking, it would have been impossible, because some of these journals, you know, give you an example, the Iranian Journal of Marine Sciences, and they've got in there one measure on brine shrimp or something like that. And why would you expect to find brine shrimp in a marine journal? Right? And so I'm picking stuff up constantly. And I mean, I'm sitting hours just Googling stuff and then refining the Google search and then going through those papers and going, oh, look, here's a PhD dissertation from somebody in Jordan, you know, or someplace else where they looked at a saline lake. And that's what I'm going through right now. And I mean, I've got huge lists of PDFs that I'm putting together. Most of the time, there's nothing useful in those papers, but you look and then all of a sudden you find one little measure. And those aren't even for the Great Salt Lake. Those are just to get started. And hopefully we then get some Great Salt Lake measures that can go in. That's where we're at. Anything else?
Go back one slide here. I got a question for you.
Sure.
Not
okay.
That's where I want to be.
Okay.
Why is excrement additive? After all, it's just another form of phytoplankton.
Because it's going into the water as a nutrient input that the phytoplankton then will pick up.
But it was phytoplankton to begin. I would think it would be neutral. You consume, and brine shrimp consumes phytoplankton. Some goes into the body, some is excreted, but it's in essence all
what goes into the
phytoplankton.
body is sequestered there.
Right.
What's
For a while.
excreted goes back, for a while until they die.
Right.
What is excreted goes back into the water so that the phytoplankton can immediately pick it up, or very shortly time period pick it up. That's why it's an additive. Because what this whole picture is looking at nitrogen in terms of the eyes of phytoplankton. And it maybe doesn't return in 1 week. There may be a decomposition element of that because it's an organic release and it's got to be pretty much put into an inorganic form. Okay. Last thing to point out today to wrap up is our GIS analysis. All of the data since 1994, the goal is to get this in so we can do GIS analysis of the data from the project. And so we've got everything, essentially everything, from 2000 to present by site, with the QC, QA completed on all of that now for 20 years. And that includes weather data, salinity data, temperature data, DO data, nitrogen data, phytoplankton data, brine shrimp data, and brine fly data. Now, the shrimp data, of course, is broken down to all the developmental stages as well. Phytoplankton is broken down not only to just chlorophyll A, but it's also broken down to the proportion of different types of phytoplankton in the water. So these are sort of conglomerate categorical types of data, not the detail. Most of the data from 94 to 99 is entered by site. We have a GIS specialist creating an interface to plot relationships that can be investigated. And here's an example, and it's wrong. Let me point out this, we plotted here, had him plot up the cis distribution in spring versus wind speed on the lake. Logically think they're floating up there, wind should be blowing them around, right? Well, the colors here of the south arm of the lake reflect the wind speed. Let's look at this, and it makes absolutely no sense. So don't get upset with me, Thomas. Got good high wind speeds, the red, the more red the color, the higher the wind speeds. You get out over the lake, there's no wind. That doesn't make sense, does it? You should have more wind over the lake than over land because of friction. Less friction over the water. Okay, let's drop the wind speeds from Hat Island and Gilbert Island. Gunnison, sorry, Gunnison. And you can see that it gets redder now out there if we drop them. Real simple, and I've told you this before, because Jim's always asked me, how come you don't use the wind speeds from them? Well, this is the average wind speed for that time period. Those wind speed stations break down under the high winds. They're absent. So what you're averaging in is low wind speeds if you include them, with a higher wind speed from the airport, and the other one is, what's the other site that's in there? There's another one on the west side, you said? Okay.
There's one on Promontory.
Yeah, that one would have been in there. But it doesn't break down like Hat and Gunnison. I mean, Gunnison, yeah.
Promontory breaks down a lot.
Does it? So what we're going to have to do is get a regression between wind speeds, and I've done this already to a limited extent, between the airport and the island weather stations, and then fill in on those dates when they are broken down due to high winds. Exactly. So that's what's going on. This is sort of problem we have to face at this point, even though we have all the data ready. There's so many holes in the data, and the data is not just random holes, it's particular windy days, let's say. So that has to be taken into account. Yeah.
Just from observations on the lake, Gary, I think that often the currents in the lake trump the wind.
It may well.
Because we often are harvesting, going with the wind just because the currents are going against the wind, and it's.
But we have no current data.
Yeah, I know, but I'm just telling you that it's something that we've observed, and that's really prevalent.
Yeah. The other thing to remember here, that what this is doing is not looking at the conditions on the day you're out on the lake. This is looking at distributions of things averaged over some time period on the lake. So it's not giving you an instantaneous picture. Can't.
No.
The data's not there to do instantaneous stuff.
I mean, I still think from observations that the currents are going to be, more of a factor.
And if we don't see any wind patterns, there we go. Yeah. Okay. Anything else? That was my last slide.
Let's see if there's any chat.
There's been current work done.
Nope.
There's people that sent out little
Yeah. Songs, boys, yeah.
or beacons.
Yeah, we tried that with the shrimp floats with radio transmitters on them, and they ended up getting buried in the lost, buried under the sediments on the beach, and that never recovered. Right, Phil? You were there when that was going on, weren't you?
No, I wasn't, but it's been legend throughout the years.
Yeah, they're still out there. We could hear them beeping in the rock pile on the railroad causeway, right? But they were somewhere worked down so deep into the rock that we could never find them.
If we find them, do you still want that data?
There'd be no data. They're dead. The batteries died long ago. It was a good idea that didn't work. The problem is though, it doesn't do it that you can average over time and include in this database. That's the problem. Yeah. Anything?
No, there's no questions.
No signal, so you couldn't.
I took it out.
Okay, thanks a lot.
All right, well, if there's no other questions, does anybody have any questions for anybody or in general before, I guess we'll actually make it on time. Yeah.
I'll make a few comments. If I can, just looking at the information that we received today, and I understand some of it is preliminary, like from the USGS. I think it just points out how important that research is. And I think there was some foresight from your end there in pushing that nutrient research. And I think as we explore that further, I think we're going to see how important that research is to the Great Salt Lake and to this project. So I'm actually really excited to see some data coming out of that. I understand that we may need to do quite a bit more over time, but I think that was, I think it's a great project. And I would also like to emphasize the process that you went through with us as TAG members to sort of look at this project and analyze it and look at the proposals. And there was an interaction with the USGS, and I thought it was a great process. And I think we're starting to see some of the benefits of that. So, you know, I think that was great. I'd like to make a general comment on the foresight of some of the state agencies and their willingness to put in an adaptive management system in the breach. I think given what we're hearing today on lake elevations and other research, that may end up being very important to ultimately managing salinity, potentially volume, and the population of brine shrimp. So I think it's that was really a great implementation. And I think that some of the work that was done here was, you know, helpful in ultimately making the decisions to implement that project. I am wondering what's going on with the bird research. We've seen Gary's work, and you know, I think also some great progress there, some questions that remain. The USGS work, I was just wondering where we're at with the bird research and what's going on there.
There is, we've kind of discontinued that, or at least for right now, I guess. I know we went through a process, what was it, about a year ago? Was it March? I thought that where we made a proposal, or Mike made a proposal as far as doing a bioenergetic study, and that wasn't approved as far as being funded. And maybe I think I may have described the process, but I described the process to the point of how I understood it, and maybe that wasn't accurate, maybe. And maybe there's, I think I mentioned at that time, we take into account all the different experts that are sitting around this table to provide input into the direction of where we want our research to go. With USGS, with Gary, with Mike and the birds. And from that, each one of our proposed research projects goes through another set of scrutiny, which is through the Research Council. And I think I described our process to that point. And then beyond that, then I don't know. Really, the only person that has a little understanding of that would be Ben, unless somebody else is on the computer that might give us an answer to that. But I'm not sure if there's a division person that's available. But or Ben, do you want to take a swing at that and describe?
I probably understand more about that than I did about all of that. I mean, that's why I'm here, trying to understand the things you guys are doing. This cycle, we're not here. We can't fund it right now, but we want to see this proposal again next year because we want to fund it. We had, I don't know, we're in a difficult year we're kind of dealing with a bunch of like ongoing emergencies right now with the drought. And the director's office felt like we needed to hold some money back to be able to plug into these emergencies that are happening in real time. And I can't speak for triage what we can do. But right now we're serious. Time. They're kind of taking some precedence, unfortunately. But part of the challenge that, and part of why I'm here, I'm the regional supervisor for the Northern Region. I do supervise John, but John and I communicate quite a bit. And this stuff's pretty high level, as you guys know. You guys are all immersed in it all the time. Administrators are not. So there are some honest disconnects that I'm trying to resolve. In the fact that the urgency of a research project is really difficult for someone.
Could you please speak louder? We can't hear you.
You know what I'm saying? So
They're asking if you can talk louder.
I'll try. But that's why I'm here. I'm trying to bridge that disconnect. But at the same time, I hope you'll understand that we are dealing with some pretty serious emergencies around the state. I'm going to drive out to Price and deal with one tonight because that's just the situation that we're in, and we're probably going to be in it for a little while. But
the main question I'm getting is, was it supported but not funded, or approved but not funded? And then what's the process? Do we rewrite it and resubmit it?
I think it just goes through the same process. If there's any refinements that can be made through the process, that would be fantastic.
Okay.
But the specific word I got was, don't let this go, bring it back.
Okay.
I don't think that means we will fund it. They can't say that. It
Right.
just isn't possible to say, but it's definitely the funding, the decision makers are very aware of it. They're very aware that they were not able to fund it. It's not like they read it and said, we don't need to do that. You know, in fact, we kind of go through an initial set of review for all of the requests and needs. We kind of do what we can, hold some back for the real-time stuff, and then they did a whole second set. And what came out of the second set were, frankly, life safety things that we needed. I had some real concerns about some biologists that could die because of some of the equipment they were using. And so I think anybody in that situation would prioritize that. And so this sort of remains after. And when that happens, I think it just kind of recycles back to the next cycle, hopefully in a further refined and ready to go.
I appreciate that, Ben. I mean, I think it's somewhat encouraging to hear that it wasn't the value of the research that made it not be funded, because we went through a process with Mike a while ago, and I think there was a lot of back and forth, and we were definitely supportive of what he was trying to do. So that's encouraging to hear, and I think gives us a little bit better understanding why it wasn't funded. I think it's important to know that a lot of the work that was done by the Great Salt Lake Ecosystem Project and supported by the TAG were always long-term. I mean, often we didn't know, ahead of time what the outcome was going to be. And as you know, it's a 25+ year project, and some of the research that was started, I mean, there was a hypothesis and there was a goal, but it was always, well, we need 5 or 6 years to figure out if that's really happening or not. And sometimes we go back to that research, like, you know, Gary does today, and find things that we didn't realize then. And so in our mind, it is important to the ecosystem that, you know, we look at all of the research on the ecosystem and look at it long term. And so hopefully that will be funded in the future.
Yeah, the way I
understand the restrictions, I get it.
I'm glad the way that you framed it though, because for me, I think it's a leadership challenge, both for John and I. Mm-hmm. You know, John's closer to the information and the data than I am. I'm closer to it than decision makers are going to be. But John and I have a leadership challenge to communicate and share that level of science and understanding to a level that an administrator can make an important decision for us. So that's something that John and I are committed to do. John has a really good reputation in our agency. There's no credibility problem with research or the request coming forward whatsoever. If John asks for it, they know it's important. And that's not a given, because we have had circumstances where in past decades where we funded research that we didn't get answers for, that didn't help guide management. And that's not how this one is seen.
Is there any other?
Just people saying they support the bioenergetics model and are very worried about the birds.
Yeah, I guess that seems to be the obvious at this point. Is probably one of the things that we won't be doing this next year. So, Laura, I don't know if you wanted to say anything or talk, I mean, kind of what Thomas was saying about the breach and the management of or the forethought that went into that. I wasn't sure if you had anything to add to that or
nothing substantive to add really, but I'm appreciative that people were open to something adaptive at the time that the breach was created. I think they were looking at, you know, a range of options, mechanized thing, and ended up with rocks as far as, you know, what we can be adaptive with. So I'm happy it's there, and I think we have people working now with water resources and with USU to understand better what's happening in the breach. So we know as the lake level is dropping, we're going to understand more how the flows are going to be impacting the lake overall, salinity and whatnot. So hopefully this next salinity advisory committee in September, we're going to have an update on the lake as the lake level continues to drop, what the salinity could look like in the south arm as the flows are impacted by the lake.
Yeah, I noticed Jeff Denblaker was on there, and that the salinity advisory committee will probably be very interested in seeing a lot of the modeled information that Gary's providing. So
one of the cool things that it may be worth having this group, or I'm not sure if it was introduced to this group, but the salinity advisory committee put together a matrix for salinity, like ideal salinity ranges for all of the resources in the lake, kind of like we did for the comprehensive management plan, where we did the matrix for all of the different resources. And they just completed that a couple of months ago. It's on the Great Salt Lake Salinity Advisory Committee's website, but that may be something worth presenting at the next meeting. But in the meantime, you guys can all go look at it and see the summary of salinity impacts per resource. Pretty exciting stuff.
Yeah, there's Lynn has a question.
Yeah, I just wanted to add my thoughts in support of the bioenergetics proposal, in that I think it's not lost on anyone that all of us are working very hard to change some significant paradigms, particularly in the Utah water law, to recognize Great Salt Lake as a beneficial use under the state water law, and to enable opportunities of water to be brought to that system. And I think to help legislators overcome some of the logical obstacles that they have with this whole request of beneficial use in the lake is to demonstrate to them that any money that would be appropriated to help bring water to the lake, there'll be a return on investment for them to know how their money actually translates into a recognized value of when we talk about ecosystem services. And so, you know, we know that the mineral extractive industries can speak for on behalf of, you know, their productivity level. Certainly with the brine shrimp industry, we have those issues that are constantly being brought to the fore. But the value of the habitat and the hemispheric significance of the bird use of the lake and this bioenergetics approach, I think would be something that would definitely be heard very loud and clearly by legislators. And again, return on investment with providing money to support water coming to the lake. So I just, you know, add my support to that proposal. I hope we can see that get funding. And there you go. Thank you.
Thanks, Lynn. Tim, you may not want to answer this, but I think the intent for this bioenergetics model was to put some real numbers on what losses we see as the lake goes down, and provide, like Lynn was saying, legislators real data, real numbers as far as information goes, rather than saying what we kind of do in our interviews now is no water, bad, water, good, because we don't really. Yeah, well, and it seems that you know, that doesn't carry as much weight as saying when we're at this lake elevation, there is no water, or there is 2 feet of water in Bear River Bay, which provides X number of forage for this particular species. Would that then, I mean, that kind of information, would that be valuable to the legislature as far as giving them real numbers as you see declines and increases in lake elevation? Would that be valuable information for them?
No, certainly valuable information. I think the more, most legislators are only now sort of gaining awareness about rates of lake. Most of that concern is really tight up, you know, and things like that. But I think as, yeah, industry, job losses, those sorts of things, that's really what draws their attention. But I think there's a growing awareness of the legislature, the importance of like anything that rounds that out is good information. So just to be clear, this 500,000, it was a $500,000 ask?
Total for 5 years, yeah, about
500,000 over 5 years. And then it was competing for what pot of money was it going after? What account was it?
It was just coming out of our internal funds.
Anyway, my point is there's a lot of different ways to sort of skin that cat, right, in terms of getting funding for research like this, particularly if we think it's important that this group is important to advance the ball. There's just some different ways to look at it where maybe it's not competing with state gear for DWR employees or the next set of waiters for Mr. and Ms. Bell's.
I gotta have a zipper. So that was
that was the review for just our base budget. That's got a certain amount of money set aside for X, Y, and Z.
This is base budget's moving to the next cycle, the next fiscal cycle.
During the current fiscal cycle.
Yeah, so like if the ask was to build it into the base budget, effectively what's said is we can't build it into our base budget this year. Does that, I don't understand, right?
Yeah, well, that's good to know because I think that was the intent of that project was to inform not just legislators or policymakers or decision makers, but also provide information to all of the managers around Great Salt Lake, not just take state-owned areas and manage them in a particular way, but manage the Great Salt Lake as a whole, since birds are obviously very mobile and go places pretty easily. I think the biggest thing we wanted to do was manage it on more of a flyway scale where we know from our monitoring data that we were able to get good information on species coming, time frames that they come here and the times that they use the lake, and then the demands that are required to as far as forage base goes. We just don't have numbers to put on that, and I was hoping that we'd be able to manage the lake more homogenously as far as when it comes to ownership. So rather than fed, state, private, we would just manage it as a whole and meet the needs for these birds all together cooperatively, rather than us, as a state in our waterfowl management areas, managing it one way and everybody else doing something different. But I was hoping that this would inform everyone what our best course of action would be as far as management goes. So I think additionally, there's you pointed out, Thomas, about the importance of the nutrient work too. And I think just some of what Gary talked about as well. And I saw Christine nodding about some of the data that is being collected and how that's being done, that we need to ensure that nutrient work is also a focus for our program, because that seems to be, again, where we're lacking in information. And I don't know if you guys, I realize you guys are working diligently on that. I'm not sure if there was anything you wanted to mention there either, because I know we certainly want to follow up on that. That's what this advisory group is here to do, is to inform and try to steer our research in the right direction. So
I kind of view the nutrient work that we're doing on the mass flux. It's, in a sense, it's going to be a ground truthing for some of these experiments that Dr. Polofsky is embarking on. So.
What's this doctor stuff?
Yeah,
they're wrong.
So,
yeah, I mean, I can take what the model produces and I can easily expand it to a longer time period to see whether it matches up, comes out in the ballpark. So that's not a problem. Yeah. But as you pointed out, the sensitivity analysis of that short time scale versus what you've got that right now I can't do anything with.
Yeah, I saw a lot of opportunities for us to work together.
Yeah.
There's a lot I can learn from you and a lot that I think we can inform.
I can learn from you.
Just because we have the field data to inform the processes you're incorporating in your model. So I think there's a really good, working relationship we could develop.
Yeah, the one thing I want to point out that the model is, it's built completely on laboratory data. So it is independent of what you're seeing in the field. So it actually allows you to test what you're seeing in the field. And when it doesn't match up, you've got to sit back and go, what's going on here?
Yeah, I think that's really neat because that's kind of where we're limited. We can't do a lot of those lab analyses. So that seems like a very, a big strength of yours. So if we can complement one another.
Oh, definitely.
Yeah, John, one more comment. I just want to reemphasize, in the past, at the TAG, we would have one meeting a year where we would discuss sort of the research. And I think more recently you've involved the TAG members in between TAG meetings when you had something that you thought was significant. And I really encourage that. I don't know what the other TAG members think, but for me, that's been a really good process. And I think really helpful to, sort of support and analyze what's going on, analyze the research proposals and come to, I think, a better product ultimately. So I definitely encourage that to continue. Personal opinion.
Absolutely. And I think part of the reason that I did that was because we had deadlines that needed to be met that would occur in between TAG meetings. And I didn't want to wait because sometimes that process would hinder us from actually getting something started at the right time. I mean, our tags kind of span over different fiscal years for the division. And so that's the purpose for getting some of the in-between meetings or providing some of the data. So yeah, certainly.
Good process.
Anybody else have anything that they want to provide before we close out? All right.